Welcome to Tomorrow Unveiled. Wow, what a week it's been, especially in wearable technology.
Absolutely. It feels like we're really moving past just, counting steps or tracking sleep.
Definitely. This past week felt like, well, like a real turning point. Technology isn't
Well,
just on our bodies anymore.
It's becoming truly integrated, deeply.
Yeah.
And that's our mission for this deep dive, which we're calling Strapped In this week in wearable tech. We want to explore how these devices are evolving so quickly.
From just simple data trackers.
Right, into these intelligent, almost seamless extensions of ourselves, extensions of human capability, really.
Driven by AI, advanced sensors, the stuff our dedicated research team has been digging into. It's quite something.
It really is. And when you say intelligent extensions, that's not hyperbole.
No, not at all.
Yeah.
The breakthroughs the research team flagged this week are, well, they're pushing boundaries. Seriously pushing them.
We're talking smart glasses acting like a second brain, revolutionary neural interfaces, both inside and outside the body.
And maybe less glamorous, but just as crucial, are these advances in how AI actually, understands the messy data that comes from living in the real world.
Exactly. That's a huge piece of the puzzle. The core shift our researchers identified is this move from passive data gathering,
Like your old fitness tracker just logging stuff.
precisely, to this active, proactive human-computer symbiosis. Wearables are becoming what the team calls agentic partners.
Agentic partners, meaning they can remember, reason, even act for you.
That's the idea. This whole strapped-in paradigm, as we're thinking about it, seems to rest on maybe three big pillars converging right now.
Okay, let's unpack those. Pillar one,
Yeah.
Agentic AI.
Right. So AI that doesn't just wait for a command. It learns, it remembers, it has a degree of autonomy.
So less like Siri or Alexa just answering questions.
And more like an active agent working alongside you, anticipating needs sometimes.
Interesting. Okay, pillar two, foundational models for messy reality. That sounds technical.
It is, but it's so important. Think about it. Real-world sensors aren't perfect. Your watch loses signal, you move weirdly, maybe clothes block a sensor.
Yeah, data gets messy.
Exactly. And AI used to really struggle with that incomplete, noisy data. But now, the research shows breakthroughs where AI learns directly from this imperfect stuff.
So it doesn't need perfect lab conditions.
Nope. It makes the insights you get far more reliable, more resilient, which is critical if you want to use this tech outside a lab, in daily life.
Makes sense. And the third pillar.
Advanced, practical biosensors. The key word there is practical. It's not just about inventing some amazing new sensor.
It's about making ones that actually work reliably, can be made affordably, and people might actually wear.
Precisely. Mass production, cost effectiveness, that's the hurdle they're clearing now.
Okay, so we've got smarter AI, AI that handles real-world messiness, and better practical sensors. Where's this all leading right now? What are the exciting impacts?
Great question. Because these aren't just abstract ideas anymore. We're seeing them show up in actual devices. And probably top of the list this week, AI smart glasses.
Right, like the Brilliant Labs Halo glasses that just launched.
Exactly. They're explicitly designed with an AI-first approach. It's less about watching videos on your face.
And more about augmenting your thinking.
That's the goal. They've got a dedicated neural processing unit, an NPU, right on the glasses for the AI.
On-device AI. That's key for speed and privacy, right?
Definitely. And a tiny little micro OLED display. Just a heads up, not a big screen. It's about context, not distraction.
So what can it actually do? The AI part.
Well, the core is NOAA. That's their conversational agent. It uses the sensors to perceive your environment in real time. It sees, it hears.
Okay, so it understands context.
Mm-hmm.
But then there's this other thing, narrative. The long-term memory. That sounds profound.
It really is. It's described as a patent-pending long-term agentic memory. The idea is it can recall details from, say, conversations or experiences years ago.
Creating a sort of private knowledge graph of your life.
Exactly. Imagine having perfect recall or being able to ask your glasses, what was the key point from that meeting last Tuesday?
Wow. That fundamentally changes things, doesn't it? How we remember, maybe even who we feel we are.
It could. It's like externalizing a part of your cognition. And Brilliant Labs emphasizes privacy. Here, they say, the rich media is converted into an irreversible mathematical representation, not stored as raw audio or video.
That's crucial. And they're open sourcing the hardware and software too.
Yeah, which is a big strategic move, could really build a developer community around it.
And what about this vibe mode? It sounds a bit out there.
It is pretty experimental. It's basically voice-driven app creation on the fly.
You just tell it what app you want.
You literally describe the app, and the AI supposedly builds and runs it in seconds. It's pushing the idea of user agency to a whole new level.
Wild. And it's not just Brilliant Labs, right? Alibaba's working on something.
Yeah, the research team highlighted their upcoming Quark AI glasses. Those seem more focused on practical tasks within their ecosystem.
Like what?
Real-time language translation, live meeting transcription, plus deep integration with Alibaba's services. Think shopping, payments, all through the glasses.
Okay, so different approaches, but the same underlying trend. Glasses becoming active, intelligent interfaces.
Absolutely. And beyond glasses, we're seeing leaps in neural interfaces too.
Like the Meta Wristband. That's not an implant, right?
No, totally non-invasive. It uses surface electromyography, SEMG, basically reading tiny electrical signals from your wrist muscles when you move your fingers.
And that lets you do what? Control things.
Yeah, the research data shows it can manage air writing at about 21 words per minute.
Typing by just twitching your fingers.
Pretty much. And seamless control for AR interfaces. The big deal is it seems to work well across different users without needing tons of individual calibration.
So making hands-free control much more practical.
Exactly, especially for AR where you don't want to be holding controllers.
Then, on the completely other end of the spectrum, Cortex brain interchange. That is an implant.
Yes, the first fully implantable wireless brain-computer interface, or BCI, that's now in human trials. Very different league.
And its focus is medical.
Primarily stroke rehabilitation, yeah. It monitors brain signals in real time and can deliver adaptive stimulation to help recovery, a major step for therapeutic BCIs.
And speaking of Meta again, their smartwatch seems to be back in the picture, but differently this time.
Right. The research suggests its reemergence is strategic. It's not just a watch with a camera anymore.
It's becoming a sensor hub for AI.
Exactly. It fuses data from its camera, its motion sensors, the IMU, and its biosensors.
To build a really complete picture of the user's context.
A rich, holistic understanding. And that context is what empowers these agentic AIs we were talking about. It feeds the beast, so to speak, makes the watch a foundational piece for their whole AI ecosystem.
Okay, so the devices are getting smarter, more integrated, but this is all built on some really fundamental research breakthroughs, isn't it?
Absolutely, like Anthropic's work with Claude 3.5 Sonnet. This computer use capability, it's a big one.
What does that mean exactly? The AI can use a computer.
Pretty much like a human does. It can look at a screenshot of a graphical user interface, a GUI, understand what's on the screen, and then figure out how to click buttons, fill forms, execute commands.
Without needing specific APIs or anything, it just looks and clicks.
That's the potential, yes. Imagine telling your wearable, book me a table for two at that Italian place for 7 p.m. tonight and add it to my calendar.
And the AI could actually navigate the restaurant website, find the booking form, fill it out, then open the calendar app and add the event.
That's the transformative possibility. It moves AI from needing predefined tools to being able to use any tool designed for humans. Real digital agency.
Wow. Okay. That's huge, even if it's still early days.
Definitely. And another major piece of research tackles that messy data problem we mentioned earlier.
The Google model.
Oh.
LSM2.
Yes, LSM2 with AIM adaptive and inherited masking. The research team really emphasized this one. It's a foundational model specifically designed to learn effectively, even when the sensor data is incomplete or noisy.
Which is almost always the case with wearables in the real world.
Exactly. So this makes the insights much more robust. You can actually trust the outputs more, even if the data stream wasn't perfect.
And that's crucial for health applications, right?
Yeah.
Trying to spot subtle patterns.
Absolutely. Think about detecting early pre-symptomatic signs of things like hypertension or anxiety from consumer device data. You need reliability, even with imperfect data collection. This model is a big step towards that.
And then there's the practical sensor side, the RMIT wound sensor.
Yes. A fantastic example of practical innovation. It's a flexible wearable patch for chronic wounds.
Does it track?
Key indicators of healing or infection, inflammation, pH levels, temperature, right there in the wound dressing.
And the key is, it's reusable and cheap.
Apparently so. The research estimates potentially below $5 per sensor at scale, and reusable. That makes advanced wound monitoring much more accessible, especially for chronic conditions that need constant tracking.
So these breakthroughs are really opening up new value, new applications. Let's talk healthcare first.
Well, the RMIT sensor is a prime example. Better chronic wound care, potentially fewer infections, remote monitoring by doctors. It's a clear benefit.
And the LSM2 model enabling reliable insights from, say, your smartwatch. That could shift healthcare towards prevention, couldn't it?
That's the hope. Early detection of disease patterns before you even feel symptoms, moving from reactive treatment to proactive health management.
Plus, AI smart glasses in hospitals.
Imagine surgeons getting hands-free patient data, or remote specialists guiding a procedure, or even AI helping control equipment in the OR, streamlining workflows, improving access.
Making healthcare smarter, more efficient.
Yep.
Okay, what about outside healthcare? In the workplace, the augmented enterprise.
Huge potential there too. Think field service technicians wearing AR glasses.
Getting remote help, seeing instructions overlaid on the equipment.
Exactly. Hands-free guidance from experts anywhere in the world. That's already happening in some industries.
And that halo narrative memory system.
Yeah.
You could see that being used for company knowledge.
Potentially, yeah. Capturing institutional knowledge from everyday interactions, making it searchable. Imagine onboarding new employees with that.
Interesting. And logistics, manufacturing.
AR glasses showing hands-free picking instructions in a warehouse or assembly steps on a factory floor, optimizing routes, reducing errors.
Even things like industrial exoskeletons are getting smarter with AI augmentation, right? Helping with heavy lifting, reducing strain.
It all points towards making work smarter, safer, and frankly more productive by integrating digital intelligence directly into the workflow.
Okay, so work gets augmented. What about our personal lives? Personal computing, entertainment.
Oh, that's where it could get really fun and maybe a bit weird. We touched on the agent-driven automation telling your device a goal, like booking that restaurant and having it just do it.
Taking away the tedious multi-app clicking.
Exactly. And think about ambient media. Your smart glasses subtly showing you stats during a sports game, or actor info during a movie, or details about the song playing.
Contextual information seamlessly overlaid.
Right. Plus, more immersive entertainment, multi-sensory haptics that let you feel the experience, better spatial audio that makes sound feel truly three-dimensional. It all gets richer.
Okay, this all sounds incredibly powerful, transformative even, but there have to be downsides, challenges.
Oh, absolutely. Big ones. And the research team was very clear on these. Top of the list. The privacy paradox.
Always on devices, always collecting data.
And very sensitive data. Health metrics, conversations, visual surroundings. The risk to the user from breaches or misuse, like data monetization, is significant.
And it's not just the user's privacy, is it?
No. What about everyone else, people you interact with who didn't consent to being recorded, visually or audibly?
Yeah, the bystander problem. That creates real social friction. Remember Google Glass?
Exactly. And the lack of clear indicator lights on some newer devices makes it even trickier. How do you know if you're being recorded? It's a massive hurdle for social acceptance.
If you're finding this insightful, by the way, and you're watching on YouTube, please take a moment to like this video, subscribe to Tomorrow Unveiled, and maybe hit that notifications bell so you don't miss our future explorations.
Definitely helps us out. Beyond privacy, there's just the practical adoption challenges.
The adoption gauntlet, as the research team called it.
Yeah. Technical hurdles first. These systems, especially early on, can be buggy. AI isn't perfect, it makes mistakes. That can be frustrating or even risky depending on the application.
And battery life. All this processing, especially on-device AI.
It eats power. Keeping these things running all day is still a major engineering challenge.
Plus cost, and frankly, how they look and feel.
Yeah.
Form factor, still barriers for a lot of people.
For sure. And then you get to the really cutting-edge stuff, neural interfaces, BCIs.
The final frontier, maybe, with its own unique challenges.
Definitely. The research highlighted this fundamental trade-off: invasiveness versus signal quality.
So non-invasive ones like the Meta Wristband are safer, but the signal is noisier, less detailed.
Right. Lower bandwidth, limiting what you can do. Invasive implants like Cortex get much cleaner, high-fidelity signals.
But they require surgery. And there are risks, long-term stability issues with having something inside your body.
Exactly. The body can react to implants over time. And then there are the security and ethical nightmares.
Hacking a BCI.
Imagine altering someone's perceptions, influencing their actions. It's terrifying stuff. It raises fundamental questions about autonomy, identity.
Questions we are nowhere near ready to answer as a society.
Not even close.
Okay, so challenges aplenty. But looking ahead, what's the overall trajectory? What does the research suggest we should expect?
Well, despite the hurdles, the momentum is undeniable. One clear trend is more AI on the body.
Meaning more processing happening directly on the device?
Yes. Making wearables smarter, faster, more responsive, And potentially more private because less data needs to go to the cloud.
We should also expect AR and assistive tech to merge more, right?
Absolutely. The line will blur. Devices that help someone with a disability might also offer features useful for everyone, and vice versa. Multi-purpose wearables.
And the hardware itself will keep improving.
Constantly. Lighter materials, better batteries, more flexible designs. The goal is seamless integration wearables that almost disappear into clothing or feel like nothing at all.
Eventually becoming almost invisible.
That seems to be the long-term vision for many.
And the overall ecosystem. Lots of players now.
We'll likely see some consolidation, fierce competition driving innovation, but also hopefully the emergence of better standards so different devices can actually work together smoothly. Interoperability is key.
So pulling it all together, this strapped-in vision, it's really about that seamless human-computer integration, isn't it?
That's the core theme our research team identified. Transforming wearables from gadgets into genuine tools that enhance productivity, well-being, and just life.
It's pretty clear this week's developments really do signal that pivotal shift. We're moving towards wearables that don't just track us, but actively augment us.
Deeply integrated intelligent augmentation.
And for you, our listener, remember, these aren't just abstract technologies. They're tools that could profoundly change how you interact with the world around you.
How you manage your health, how you work, how you learn, even how you remember.
A future where technology is truly woven into the fabric of your experience.
It's quite a future to contemplate.
Indeed. And if you're listening on a podcast service like Apple Podcasts or Spotify, we'd be incredibly grateful if you could leave Tomorrow Unveiled a rating and review. It really does help new listeners discover the show.
And we genuinely love hearing your thoughts.
Absolutely. Whether you're on YouTube or your podcast app, drop a comment. Let us know what you think about this week in wearable tech. What excites you? What concerns you?
We read them all. And maybe one final thought to leave you with this week.
Go on.
Consider this. As these devices learn more and more about you, your personal memories via something like narrative, your minute-by-minute health data, your environment, what new questions does that force us to ask?
Questions about?
About the very line between our personal identity and this increasingly powerful digital augmentation. Where do you end and the tech begin?
That's a deep one. A question for tomorrow.
Unveiled today.
Exactly. We'll see you next time on Tomorrow Unveiled.